rods only. Rods only. What is there in that? Shoe na? Two shoes of resistivity rho 1 and rho 2 gone to MRP. Two rods of resistivities rho 1 and rho 2 are added in series. Then find effective resistivity of the combination. Effective resistivity of the combination. In that second question, find rho effective in parallel combination for the same rods. How much? 2 by rho 1 plus rho 2 na. For which one? Series combination na. That's correct. See, in series combination, which will be same? No, I'm not asking about the current and all. Area will be same. Whenever you are making in series, nothing but area will be same. So, what is the answer for the first one? Rho 1 L1 plus rho 2 L2 by L1 plus L2 will get. Correct? Huh? You have to take R also, rho effective, L effective and then A effective. This one you have to take rho effective, L effective and then A effective. That is equals to rho 1 L1 by A1, rho 2 L2 by A2 you have to do. That is about the series combination. What about the parallel? In parallel combination, length will be same. Video. See that? In series combination, check your answers. In series combination, what will be same always? Area will be same. Then only we can add in series as a uniform rod, uniform combination. So that here area is same I am saying. So that everywhere area is A only. And the lengths are different lengths, that is L1 and then L2. Now you have to find out the effective resistivity. For effective resistivity, we have to take the equation of resistance R is equals to rho L by A. So for the effective rod, this is totally entire rod. I will take it as a effective rod. For that effective rod, R is equals to, what is the formula for us? Rho L by A. Rho effective, L effective by A effective is equals to, which combination this is? Series combination. Let us consider this is R1 and then R2. Series combination means what will you get? Simply R1 plus R2 only. So that in the place of R1, what I can write? Rho L1 by A1 plus rho 2 L2 by A2. But what I said, area is same. So for the combined rod also, even for the different rods also, area is same only. Then what is remaining here? Rho effective. How much L effective I got now? Total L is how much now? L1 plus L2. So that L1 plus L2 is a combined rod we got, and then rho 1 L1 plus rho 2 L2. Then rho effective is equals to rho 1 L1 plus rho 2 L2 by L1 plus L2. Now if in case they have given the lengths of the same rod, same lengths only, rods of same lengths, at that time what I can say? L1 is equals to L2. If L1 is equals to L2, what is the answer you will get? Rho effective is equals to rho 1 plus rho 2 by 2, right, you will get. If you get the 2, nothing but rho 1 plus rho 2 by 2. Yes, that's correct. Rho 1 plus rho 2 by 2. This is arithmetic mean you will get. Arithmetic mean of the resistivities gives you the series combination effective resistivity. In case of same thing in parallel, listen first, later on you can copy. In case of parallel combination, which will be same in parallel combination? Length will be same. L will be same and then area might be different, like this I have taken the different areas as A1 and then A2. Now again bottom one is also having the length L only. Now this is parallel combination, nothing but generally R effective is equals to what we will get? R effective is equals to R1 R2 by R1 plus R2. We will take like this. Now you have to find out the effective resistivity, nothing but first of all take R effective. R effective is equals to, we will take simply by the R1 and then R2, 1 by R1, 1 by R2 like that, then it will be easy for us as per this problem. Now 1 by R effective is equals to 1 by R1 plus 1 by R2 will get 1 by R effective. What is the R value for us? R is nothing but what? Rho L by A. 1 by R nothing but A by rho L, correct? So that A effective by rho into L effective, that is equals to, this one will be what here? A1 by rho 1 L1 plus A2 by rho 2 L2. What will be same I said? Length is same, so that L gets cancelled. Now we are getting here it as rho effective is equals to what I can get, otherwise directly we can take the combination also. Rho effective is equals to, I will send this one this side and then this one down. Then what will get here? A effective nothing but total area is how much now? A1 plus A2. So that A1 plus A2 is the area, that divided by A1 by rho 1 plus A2 by rho 2. If I say areas are same, A1 is equals to A2, what will you get there? A1 is equals to A2. Then what will you get? You substitute A only. A plus A, how much that is? 2A divided by A by rho 1 plus A by rho 2. So what I can write here? Rho effective is equals to, can I write it as 2 rho 1 rho 2 by rho 1 plus rho 2? Correct? I am taking all the LCM at a time and then I am saying you, otherwise I will solve. Is on here only. I said A, both are A's are same only, so here A plus A divided by A by rho 1 plus A by rho 2. Then this will be how much here? 2A by, I will take rho 1 rho 2 as a LCM, then this will be rho 1 rho 2 into A I will take out. Then A gets cancelled, however you are getting the same answer only. So 2 rho 1 rho 2 by rho 1 plus rho 2. Whenever you are taking the wires in the series combination, then your effective resistivity is arithmetic mean of resistivities. Whenever you take the parallel combination, at that time harmonic mean of the resistivity. Simple way to remember the formula I am saying. So that will be arithmetic mean, this will be the harmonic mean, 2 rho 1 rho 2 by rho 1 plus rho 2. Clear, right? That is a parallel combination and this is a series combination. Don't consider that as series means rho 1 plus rho 2, parallel means 1 by rho 1 plus 1 by rho 2 like that. Clear? Huh? Copy that. No, sir. ఇదేంటి షార్ట్ సర్క్యూట్ ప్రాబ్లమా? Anybody sitting in the chair? Plastic chair? Who is that last? Huh? Come here. Here also place is free, no? Why they are not allowing to sit? क्या जी आयशा? Fight करिए क्या सबसे? Come and sit ma. Right, done? See that? Here series combination, listen again. So here series combination I have taken of 2 wires of resistivity rho 1 and then rho 2, lengths are L1 and then L2. Obviously in series combination, I said so many times in combinations, in series combination area will be same, in parallel combination what will be same? Length will be same. So area is same and then I have find out the effective resistivity here. For finding the resistivity, first of all you have to take the resistance of the first wire is R1, resistance of the second wire is R2. The net resistance in series combination what it will be? R1 plus R2. Now R is equals to R1 plus R2. R nothing but the effective resistance. Total rod, we are talking about the total rod. For the total rod, rho effective will be there. L effective will be how much total rod? L1 plus L2. That divided by A effective is area, A only again same area. That is equals to rho 1 L1 by rho 1 L1 by A1 nothing but this is the resistance of the first rod plus resistance of the second rod. Then area is same in series combination. Series area is same. Then area gets cancelled. L effective nothing but total length L1 plus L2. And then we got the rho effective as rho 1 L1 plus rho 2 L2 by L1 plus L2. If they have given of the same rod, same length rods, at that time what will get nothing but L1 is equals to L2 if you substitute. This length gets cancelled. Here 2L will come. So only rho 1 plus rho 2 by 2 we got. This is the arithmetic mean of the resistivities. Arithmetic mean of the resistivity. Because why? Because we are having how many rods here? 2 rods, so that only we got rho 1 plus rho 2 by 2. Then in the case of parallel combination, you have to find out again effective resistivity means for the simple formula purpose. Even you can take this one also, you can solve it. But directly I am taking this one. 1 by R effective is equals to 1 by R1 plus 1 by R2. 1 by R effective nothing but I am talking about the total rod. This total rod is having how much area? A1 plus A2. Combination. This is A1 and then this is A2 means combination will have how much area? A1 plus A2 only. So that only A effective divided by rho effective by L effective. Why? Because we got the resistance as rho L by A and then 1 by R is equals to how much I can get? A by rho L. So effective resistance is equals to effective area by rho effective L effective. And then that is equals to first one and then second resistance. Then after that in the parallel combination, length is same. Always you have to take the length as same, then only you can make the uniform combination. So that L will get cancelled everywhere. Then remaining I have written rho effective is equals to A1 plus A2 by A1 by rho 1 plus A2 by rho 2. If areas are same, if area is given as the same, then what you have to get here? 2 divided by rho 1 plus rho 2 by rho 1 rho 2 we got, and final answer is rho effective is equals to 2 rho 1 rho 2 by rho 1 plus rho 2. This is the harmonic mean and that is the arithmetic mean. Clear, right? Yes. Next Kirchhoff laws will start. Kirchhoff laws. Kirchhoff laws. First Kirchhoff current law. Kirchhoff current law. So in Kirchhoff laws, mainly one technique will be there for the traveling. You have to travel along the circuit, in which direction you have to travel and then what you have to take. Nothing but you have to take, sometimes you will take plus 5 volts, sometimes you will take it as minus 5 volts, sometimes you will consider the resistors and then you will not consider the resistors. That and all are the techniques. Once you know how to travel along the branch, or otherwise how to travel along the circuit, then you can write any equation. So and also most of the problems, 90% of the problems I will tell without using the KVL only. KVL you are using nothing but minimum you will take 3 to 4 minutes time for one problem only. There is no need to take that much of time. By the nodal methodology I will tell you, nothing but by selecting the higher potentials and then lower potentials, by taking anywhere 0 as a potential and then you are taking the other voltages as a different voltages, then we can find out the answer very easily without KVL and all. Clear, right? So first of all KCL. What the Kirchhoff current law states? Currents entering the junction is equals to currents leaving the junction. Otherwise the sum of the currents at any junction is equals to always what? 0. And this will be based on one conservation. What is that? Conservation of charge. The Kirchhoff current law. In current what is there? Obviously charge only, right? So that Kirchhoff current law is based on the conservation of charge. And also the currents entering the junction is equals to currents leaving the junction you have to take. That is about the Kirchhoff current law, very easy one. And then Kirchhoff voltage law. What the Kirchhoff voltage law states? What is the Kirchhoff voltage law? The sum of the EMFs in a closed loop is always equals to 0. whenever I consider any closed loop like this, the sum of EMFs, let me take in this current I is travelling nothing but this is a closed loop. In that closed loop, sum of EMFs, otherwise sum of voltages is always equals to 0. So that the net voltage in a closed loop is always equals to 0. This is based on, I am talking about the voltage means I am talking about the work done. Voltage is nothing but what? Work done only, right? So that work done nothing but energy only. So this is based on which conservation here? Conservation of energy. And then KCL is based on the conservation of charge. So that also important. Those points also important. And then you have to mainly remember that in this KCL at any junction, let me take, I have this junction here. Let me take I1 is entering and then I2 is entering, I3 is leaving and then I4 also entering. So what I can say nothing but here, the sum of the currents at the junction is always equals to 0. Sum of the currents at the junction is 0 means you just consider it as currents entering is exactly equals to the currents leaving. So that who is entering here? I1 plus I2 plus I4 is equals to who is leaving? I3. That's it. Finished. Then in this case, how to write the equation I will tell you. First of all, you have to get to know how to write the equation. Then only you will write the equation. Clear? So KCL is based on the conservation of charge and then KVL is based on the conservation of energy. Write that. KCL and then KVL. First KCL you write. The sum of the currents entering the junction is equals to sum of the currents entering the junction is equals to sum of the currents leaving the junction. Sum of the currents leaving the junction. In the next line, based on conservation of charge. Based on conservation of charge. Next one, KVL. KVL. The sum of the EMFs, sum of the EMFs, sum of the EMFs in a closed loop, sum of the EMFs in a closed loop is always 0, is always 0, and based on conservation of energy. Now this is one branch of the circuit I have taken. Listen from here properly. So this is one branch of the circuit I have taken. In that very big circuit is there, and in that I just removed one branch. In that the current is flowing in this direction. Current is flowing in that direction. Now you have to find out the potential difference between point A and B. How to do this means, first of all you have to take the current direction as your original direction. You have to travel along with the current. They might be given the current here, even here also. They will not give here and then directly they will give here only. So don't worry about that, anywhere they have given, but the direction you have to observe mainly. The direction is there from where to where? Left to right. So start at the left. This is the current I, and then everywhere is current I only. Why? Because everything is in which combination? Series combination. So current distribution will not be there. Same current will pass throughout the branch whichever we have taken. Now here the current is flowing from left to right. Left to right nothing but what you have to consider, first of all A, and then you have to travel to point B. Now first of all you have to take everything, you have to travel, and then finally is equals to VB you have to write. Let me take at point A the voltage is VA. You are only considering, we are just finding the potential difference. So that you are only taking that as a VA. Listen properly, if you don't listen this you cannot understand any problem. So listen and then understand the technique. So here I have taken the potential as VA. We are only considering that there is no problem in that. Now at this point the potential is VB. Now first of all, from where I said you have to travel? Along the current direction, left to right. And also in the resistor, always along the resistance, in the current direction flow, always potential will decreases. What is the reason? Current will flow from higher potential to lower potential only. Along with that, in the resistor what happens? Nothing but the current, the potential drop will be there across the resistor. Why? Because resistor will reduce the current obviously. So what you have to take? Nothing but whenever you are traveling in your middle way, whenever you got the resistance, there you have to take the negative potential. Why? Because the potential is dropping there. The resistor is taking the potential. If the resistor is not there, there is no potential difference between this point and then this point. You are understanding or not? For example, I have this one as the same line only. Then if this is a VA means even this is also what? VA only. I said in the short circuit problem for you. Yes, sir. Whenever the resistor is there, at that time that resistor is reducing the value of voltage here. Why? Because voltage is dropping across the resistor. So that wherever you got the resistor, then simply you take the potential as negative in the resistor. And also for the battery there is an important technique. We are traveling from the negative potential to positive potential. You have to take it as a plus, nothing but lower potential to higher potential, nothing but you are increasing the value, right? Low to high. So that plus V you have to take. If you are traveling from plus to minus, at that time what you have to take? Minus. Why? Because you are decreasing the potential there. Lower potential to higher potential, what you have to take? Plus V. And then higher potential to lower potential, minus V. One is for the resistor, I said. For the resistor, always you have to take minus IR only. In case the current is coming opposite to you. For example, I have taken another branches. For example, if I take the KVL, at that time I will tell you that nothing but it will come in the Wheatstone bridge. In Wheatstone bridge, current division will be there, right? So here the Wheatstone bridge will be there like this, half of the circuit I am drawing. Now in this current will flow in this direction, in this one like this. Now whenever you are traveling in this way, this current is coming opposite to you. At that time it will be different. What it will be? Nothing but you have to take plus IR. Whenever the current is coming opposite to your direction, at that time you have to take it as plus IR. Otherwise what you have to take? Always minus IR only. You are writing the sum of potentials here. Potential across the resistor, potential across the batteries. So for the batteries, you are traveling to from lower potential to higher potential, what you have to take? Plus V. From higher potential to lower potential, minus V. For the resistor always minus IR. If the current is coming opposite to you, at that time it will be plus IR. Clear, right? Now you have to write all the potentials, only potentials you have to write. For this one, now I will start from point A. At point A, what is my potential here? VA. We are traveling in which direction? Left to right. Clear? Now first of all I encounter with the 2 ohms resistor here. What you have to take? The current direction is same and then your traveling direction also same only. So what you have to take? Minus IR. So that VA minus I into how much resistance is there here? 2 ohms. All the potentials only, minus VR, minus IR. Then again you are traveling from where to where? Lower potential to higher potential. Increasing or decreasing? Increasing. Increasing, nothing but what you have to take? Plus 5 volts. Clear? And also whenever you are coming here in this direction, you are going nothing but minus I into resistance is how much here? 1. And then you are traveling from where to where? Plus to minus, higher to lower. Nothing but what you have to take? Minus 2 ohms, minus 2 volts. And then again what you got here? Minus I into 2 is equals to, finally I reached point B, that is VB. Clear? Now let me take in this current flowing is 1 ampere. Then what will get here? VA minus 2 plus 5 minus 1 minus 2 is equals to VB. Correct? I am just substituting the I value as 1, that's it. Now what will get here? This will be how much? VA minus VB is equals to how much will get? 2 to 6. 2 na? Yes, 2. 2 volts is the potential difference here. You understand how to write that? Clear? Now I will give you another one. You have to find out that. Before that you just write, first of all copy this and then write the technique also. For Find the potential difference between A and B for the given part of the circuit. Copy that first of all. Pavitra, good morning Pavitra. Good morning. At least while writing you wake up, Amma. ಅಷ್ಟು ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದ್ದು ಅಂದರೆ ಏನು ಅರ್ಥ ಆಗುತ್ತೆ ಅಮ್ಮ, ಸರ್ಕ್ಯೂಟ್ಸ್ ಏನು ಅರ್ಥ ಆಗಲ್ಲ ನಿಮಗೆ. Get chocolate packets and keep eating that, at least in my class. Shall we do in opposite direction? Yes, otherwise you will get confused. No, right? We will travel in this direction, opposite direction. Opposite direction we will travel and then we will write the equation. From where I started first? B I am starting. So that VB, listen here again, VB. And then after that we are coming in this direction, but I am getting the current in opposite direction. So what will you get here? Plus IR. Whenever the current is there opposite to your direction, at that time it will be plus IR. क्या चल रहा है उधर last bench में? Huh? You are not able to see this. You are sitting in back bench means how can you sit? How can you see that? All the boys are already, these are extra large people. No, for you this many people have to bend means it is not correct thing. You can get the chairs and then you can sit here. Huh? क्या कहते Shreyasa. Yeah, see, everybody will follow Shreyas only. I don't know what is the reason. So that is what he is thinking inside. Why me only? Hostel boy. Hostel ಬಂದಿದ್ರಾ? Great. ಅವ್ರ ಅಮ್ಮ ಅವ್ರ ಲೈಫಲ್ಲಿ ಏನೋ ಒಂದು ಒಳ್ಳೆ ವರ್ಕ್ ಮಾಡಿದ್ರು ಅಂದರೆ ಇದೆ. So here you are starting at what? Point B, right? So you are starting at point B. You are going in this direction, but the current is coming in opposite to you. Whenever I said current is coming opposite to you means what you have to take? Plus IR. And battery direction is same only. Battery plus 2 minus means it will be low, that will be minus V you have to take. And then minus 2 plus nothing but what you take? Plus V. Okay. Now I am coming in this direction. See that this one is entirely different and then this one is different. Let us see we will get the same answer or not. So VB I am starting at. First of all I will write VB. And then current is coming opposite to me, then what will write here? Plus IR. So that plus 2 into I. Then what will get here? You are traveling from minus to plus, lower to higher. Nothing but what you will get? Plus 2 volts. And then here you are coming in this direction, but the current is coming opposite to you. What will you get? Plus I into R is how much here? 1. And then plus 2 minus, higher to lower. Minus 5, and then here also opposite only, what will you get? Plus 2 into I. That is equals to finally where you are reaching? A. And then this is 1 everywhere, 1 only. Then what will you get here? VB minus VA is equals to minus 2 volts you will get. That's it. Again VA minus VB is equals to what will you get here? Plus 2 volts only. That's it. However you might be travel, but you have to take the components as correct. Clear, right? Only follow this one. Don't go for that one. This one is enough. Don't copy that. Just I told you whenever you are traveling in opposite direction how you have to take. Now here, listen again, I am starting at point A and then reaching the point B. You have to decide whichever the direction you want, you can decide that. Means whenever you don't have the current here, just consider this as I is flowing in this direction, and then you are also traveling that direction only. So that in this direction I am traveling in the right side direction. So that for that what you have to get nothing but first of all you are starting at VA and then ending at what? VB. First of all let us start at VA. At this point I have the potential how much? VA, and then in this direction current is flowing how much? I. We are getting the resistance how much here? 2 ohms. We are traveling in the direction of current. In the direction of current potential will decreases in the case of resistor. In the direction of current potential will decreases in the case of resistance. Decreases nothing but what you have to take? Minus. So that only here minus I into 2 I have taken, I into R. And then you are traveling from where to where? Lower to higher potential. Lower to higher nothing but you are increasing. Increasing means what you have to take? Plus 5 volts. And then in this resistance again what I said? Potential will decreases, so only minus IR. And then in this battery you are coming from higher to lower potential. Higher to lower potential nothing but your value is decreasing. Decreasing nothing but what you have to take? Minus 2 volts. And then in this one again potential is dropping, so what you have to take? Minus I into R. Finally I am reaching at point VB. Clear? And then we can get the VA minus VB value directly. Clear, right? Write that technique first of all. Decide the current direction. Decide the current direction. Decide the current direction and travel through the current direction. And travel through the current direction for writing the sum of potentials. For writing the sum of potentials. For writing the sum of potentials. In the next line, in case of resistors, always potential decreases. Always potential decreases in the direction of current flow. In the direction of current flow in resistors. In resistors. So potential should be considered as minus IR comma in any one branch encountered with a current opposite to the direction opposite to the direction of traveling, then potential across the resistor should be taken as positive. Should be taken as positive. Should be taken as positive, that is plus IR. You understand the point, right? Whenever you are traveling in the resistor, obviously potential will decreases, so that what you have to take? Minus IR. If the current is coming opposite to you, at that time what you have to take? Plus IR. That's it. Next, battery. Next line, battery. For the battery, if the direction is there from, if the direction of travel is from lower to higher potential, lower to higher potential, what do we have to consider? Plus V na minus V na? Plus V. Lower to higher potential, then plus V should be considered. Plus V should be considered, comma. If any battery is connected in opposite direction, connected in opposite direction, that is from higher to lower potential, then negative potential to be considered. Negative potential to be considered. Clear? Shall I give one problem? Yes. Find VA minus VB. Two amperes. Any answer you got? How much? Huh? 18. 18, 1 8. You? Write that. Solve properly. 18, 18, 18, Tamil 18 ಏನೋ ಅಂತಾರೆ ತಮಿಳಲ್ಲಿ 18 10 అంటే 10 అనే అర్థ 18 finished 18 is the answer. Yes, very good. See that at A you have to travel. Listen again, whoever did not understand properly, listen properly. Now here we are traveling at A. Start at A, VA. First of all, what we got? Battery. Battery from where to where we are traveling? Decide the current direction, this direction we are flowing. So that only here plus to minus nothing but what will take? Minus, higher to lower nothing but minus 10. And then what you have to take? Minus 2i, and then minus 2 plus nothing but plus 10. And then minus 2i, plus 2 minus nothing but minus 2, and then minus 2i is equals to 0. VB, yes, VB, that is what you have to write. All the potential across the voltages as it is, whatever they have given, that you have to take. Potential across the resistor is what you have to take, I into R, minus IR only you have to take. Now what is the answer? You will get VA minus 10, this will be how much? I has given us 2, minus 4 plus 10 minus 4, and then minus 2 minus 4 is equals to VB. Plus 10 minus 10 gone, then 4 16 18. VA minus VB is equals to 18 volts. That's the answer. Finished. Clear, right? Yes. Chalo, we'll start from loop problems. We'll start. Before I'll give one problem to you. Find out the current flowing in the circuit. Find the current flow. Anything, you can decide any direction of the current, you can get the answer. There is no problem in that. IA ಕಂಡಿಡ್ಬೇಕಪ್ಪ. IA ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಮದುವೆ ಹೋಗಿ ಬಂದಿದ್ದು ಚೆನ್ನಾಗ. ಎಷ್ಟು ದಿನ ಹೋಗಿದೆ? ಇವತ್ತು ನೈಟ್ ಬರ್ತೀನಿ, ಬೆಳಗ್ಗೆ ಬರ್ತೀನಿ, ಈವ್ನಿಂಗ್ ಬರ್ತೀನಿ ಅಂದ್ವಿ. टू 3 ना 10 minus 5 plus 5 minus 10. Yes, correct. Very good. 3 is the correct answer. Loop, right? Sum of the voltage should be equals to how much? 0. I'll tell you how to travel in that. I'll tell you. First of all, try to get the answer. That's it. 3 amperes is the correct answer. ಏನು ಡೌಟಾ? ಏನು ಹೇಳು. ನೀವು ಯಾವ ಡೈರೆಕ್ಷನ್ ತಗೊಂಡಿದ್ರಿ? ಅವೆವರ್ ದಟ್ ಈಸ್ ಮೈನಸ್ ಓನ್ಲಿ, ಇಟ್ ವಿಲ್ ಕಮ್. ವೋಲ್ಟೇಜಾ? ಬ್ಯಾಟ್ರಿ ಪ್ಲಸ್ ಬರುತ್ತೆ. ನೀವು ಈ ಥರ ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ತಗೊತಾ ಇದ್ವಾ? ಹಾಂ, ಕ್ಲಾಕ್ ವೈಸ್ ತಗೊಂಡಿವಂದರೆ ಅವಾಗೆ -10 ಬರುತ್ತೆ, -10i ಬರುತ್ತೆ, -5 ಬರುತ್ತೆ. ಕರೆಕ್ಟೇ ಆನ್ಸರ್. 3ನೇ ಕರೆಕ್ಟು. ಕೊಡು, ಪೆನ್ ಕೊಡು. 3 you got 1. Whichever the direction you consider, you will get the same answer only. There is no change in the answer. Wait. -5i. 1 is the answer. 1 is the answer. Not 3, 1 is the answer. How many of you got that one? Yes, very good, very good, very good. Look at this. You can consider any direction as a current. You can either consider clockwise direction or anti-clockwise direction. But if you see here, 10 volts battery is bigger, right? Just assumption only I am saying. I am not telling this is a fixed. So here 10 volts is a bigger battery. So that what you can say nothing but 10 volts only will give the current. ఎందుకు ఆఫ్ అయింది? టైం అవ్వలేదు ఇంకా.